Say hello, everybody. So this session is about a slightly technical, nerdy topic, open source. Um, Lots of people were asking me about, saying we've come across this topic of open source. People particularly using NHS data to do some analysis with, talking about open source. So I said I'll put together a session on open source for you. So first of all, I've only used a limited amount of open source in my professional life. It's relatively recent-ish, the ability to do this thing. But I explained to you what it's about, where it came from, how the NHS uses it, what the benefits are, and some things you might come across in your either daily lives, which is open source, or particularly in the work we do with the NHS and universities and research groups, how they may be using these things as well. I shall apologise for the croaky voice, because I do have a bit of a cold, but because I'm a brave soldier, I shall plough on. So let me share the screen. Hopefully you can see the screen. So what is open source? Why does it matter? And in the next 20 minutes or so, I'll try and go through these things. If you've got any questions, probably easiest to wait for them to the end so they don't mix up on the recording. You can use a chat if you want as well. So first of all, open source, what the heck is it? So when we talk about open source, we're really talking about software, computer programs, bits of computer technology that do something with data. So it's really just software, and software itself is a general term for programmed or data instructions on a technical device, electronic device, to make it perform tasks, to do something. So programs are things that force a computer to do something. Open source is a form of that software. So it's not particularly complicated in what it is, but some examples. If you look at software generally, you'll see software on everything that you've got. So you may be wearing a watch now. Your watch runs on software. It's a program to instruct the watch to do something when you press a button. It's exactly the same thing with your phones. Modern day phones rely on very, very complex software to make them run, as do laptops and things, as you'll have seen. And software also runs the connectivity of the World Wide Web and the way the NHS sends data between its different sites. All that's done by software through a network of wires across the country which run the NHS network. So all those things rely on software. Open source is a type of software. So software is everywhere. It runs the world we live in. So open source itself, so there you can have that for free. That's my analogy of what open source is. It's software that's developed by somebody, but particularly with the concept of sharing it so that anybody can use it, look at it, change it, modify it, create their own versions, distribute it. So it's a very different way of producing software, things that manipulate and use data, um, in a sort of family setting in a way. So anybody can see it, anybody can use it, anybody can distribute it. If you contrast that with what you might call proprietary or closed source software, that can't be modified, that can't be redistributed without copyright holders' permission. So you never own that software. There's a clear owner of the software. Without their permission, you can't change it. And by and large, you won't be given any permission to change the software. That's closed source. So one person develops it, one person controls it, one person understands the techniques of what it does. Nobody else can really see that. And open source originated from computer programmers, as were, who simply wanted to figure out the best ways of doing things with data. And they needed to, obviously, share software between each other to learn from each other. And that's how it started. Groups of software, I think it's from the US, groups of programmers got together and said, wouldn't it be good if we could just see what each other were doing in a really easy setting, rather than saying, I'll send you a copy of my program by email. And we don't have it in one place so we could all see it, so we could all use it, so we could all develop it. And that's what open source is about. The source of the software, the bits that you can see, the instructions, remain open. The software you've got on your laptop or your phone, which you're viewing at the minute, is generally what used to be called compiled software. So even if you looked at it, you couldn't understand what it is because it's completely uninterpretable. Open source, you can look directly at the program, you can work down the coding of the logic, and you can, in many cases, change it yourself or create your own version or redistribute it. So it's fundamentally different to the way software has previously been developed, sold, deployed. So some examples that you might recognize. There's just two up there. I'll come to some more later on. Cover these later on. Many of you will got Windows on your computer, and you'll have got a version of Microsoft Office, which you'll have paid, I don't know, for instance, was £70 or something per year to run as a license. So that's proprietary software. You can't change that software. And it's produced by Microsoft, and they take the money and the credit for doing that. There's an alternative to Microsoft Office called OpenOffice. Now, you can go on, you can download that, and if you wanted to, you can edit the source code of that. You could edit what it does. You could create your own little versions of it. You could suggest improvements about that OpenOffice software. And the two on the bottom, the little round one on the left is Firefox, which is a browser. Some of you may be using Firefox now. That's an open source browser. So the development of that browser is done by a community of people who are interested in software development. They can see all the source code, they can make changes, they can suggest things, they can talk to other people, they can try things themselves. Google Chrome or Microsoft Edge, you can't do. You just download it, you install it, and that's what you run. So it's quite different. And there's two examples of that. And I'll come to some other examples of open source software which have equivalents in the commercial world. So why does it matter? And why does it matter, in particular in the way our patient data gets analyzed? So you'll see from just hearing about the conceptual thing about what open source is, what the philosophy is. It fosters that community. So we all will have seen analysts at different conferences and data scientists and research from all over the country and indeed internationally. Um, Imagine if you could just foster their intelligence, their knowledge, their technical skills in one way so that one group in Edinburgh could share much more dynamically with a group in Oxford and a group in London and a group in Belfast and a group in Cardiff or wherever. So open source software give you the ability to directly share things and knowledge with other people of your life, like developers, analysts, data scientists. It also lets them collaborate and really innovate. So they're all working on the same source code. It's not owned by anybody in particular. It's a collective that helps to develop that code. There is version control in there to make sure it works, but essentially anybody is part of the community. And the theory is it should lead to better solutions. So whilst it might take Microsoft 5 years to develop a version of PowerPoint, well, if you've got hundreds of developers over the country doing it, you might think you develop something better, faster, much more effectively that actually people want to use. And it's the same with the analysis of our patient data. Um, it could lead to different, better ways of analyzing, of understanding what is very complex data. And I'll share an example of that in a second. Um, the other thing to realize, as I mentioned, is that when people are analyzing our data, the analysts, the researchers you will have come across, the data is really, really, really messy. I couldn't have put really in enough times on that. It's a right mess generally. Some NHS data is coded, so it's more structured, but even within that, there are problems. Lots of data within the NHS. I think I saw stats that 80% of useful data in NHS is free text, isn't coded, and it's really, really messy. If you've read any of your own pathology reports or even consultant letters you may have seen, they're all sort of semi-structured, but they're all free text. Trying to get a computer to understand that is really messy. So because of new techniques that are around in data science, we're now moving to a point where we can begin to get computing programs to try and understand what's in a message, what's in free text, what really it is saying, how to take the insights out of that. But it's really, really messy. It takes a heck of a lot of effort and a heck of a lot of work to do something which might feel quite simple. But once that's been done, it really makes sense if you've got groups of researchers looking at the same type of area for them to be able to have an environment and a philosophy to share their knowledge, to share their insight. Um, so let other people check what it is they've done, maybe correct it, maybe put some suggestions in. It's sort of an internal peer review. This can be challenging for people because open source means anybody can see it. So I could go in and look at, as you'll see in a bit, some open source software that's been developed to manipulate a piece of data or to derive some information from medical records. And I might think, well, I'm not sure about that. So it opens up a whole set of questions. It also means that I could, in theory, go and take somebody's knowledge and take it further, and I could benefit from that. But actually, that's what a community is about. So you've got to balance these things around. So anybody can expect the code and the logic. And the key thing is that it remains open. So it's not a black box. So somebody said, how did you do that? How did you come up with the answer of 50? There you are. You can look at the software, you can look at the code, and you yourself can check it. it's showing or working out, as the wonderful graphic says. So here's a very, very simple example that you might have in the NHS. Want to count the ethnicity of diabetes patients by sex. So a researcher gets a data offload, which might look like that. So it's got some pseudonymized or some jumbled numbers on the end on the left. That just allows individual records to be associated with the same person, but you don't know who the person is. What you do know is they're female, something happened in January, something happened in March, something happened in September. So those are all for the same person, events that have happened to that person. But the only thing I've taken from that event record is the ethnicity code that recorded at that time. And you'll see, fairly typical of NHS data, there's inconsistency. The first event, somebody recorded that the person was white British, then it was said not known, then white British again. Now, if you're a researcher doing some work on ethnicity, in this case counting, you've got to figure out, well, what do I do with that record? Well, what a researcher does, it's got two researchers here, researcher A and researcher B, and researcher A will say, okay, my logic here, I'm going to use for each person the most common ethnicity value that I see across their records, their events. So in this case, they'll say, well, I've got white British and they're not known as a white British, so I'm going to say that person is white British. That's going to be my assumption. These are the things that researchers do all the time to work with poor data, with incomplete data. Researcher B is 100 miles away. They're trying to do the same thing. But their logic says, well, I reckon I'm only going to derive the values where the values are the same for each. In this case, they'll say, oops, I've got white British, I've got white British. So actually, they're not all the same. I'm going to say no. I'm going to be very safe. I'm going to exclude that from my results. Now, the researchers could be working with exactly the same problems, exactly the same questions with exactly the same data, but their answers are going to be different because their logic is different. Both are valid. There's clear reasons why somebody might want to take that decision when they're trying to derive ethnicity, and they come up with different results. Like that. Now, that's a very, very simple example. Data sets are hugely complex and are very large, very long, and very complex, and significantly higher numbers. 3, this event record I've got here. So researchers will make these decisions all the time. And when they get to the end of their research and publish the result that said the answer is 42, another researcher doing the same thing with the same way could say, actually, I've got the answer 53. Open source would let you go back through each one of them and share the methodologies, share the logic of doing that. So the other benefits are, in that case, the two researchers could compare their methods, could compare their workings and come up with either to say, no, I'm happy with mine, but that it's different because of these reasons. Or they could say, no, let's become a bit more convergent. Let's say the best thing we reckon is to go with researcher A's logic and researcher A algorithm. And anybody else could then use that as well because it's all open source. So in that way, you begin to see this more of an educational opportunity. So as we get young data scientists, young researchers coming in, wanting to work and understand complex NHS data, they can access this platform of shared logic, all the algorithms, and use it as a learning tool. So they can say, how have other people got around this problem? Can I adopt it? Can I suggest it's improved in a different way? So it becomes a much more collective thing. It also means that as people are coming into this world, in theory, the learning curve should be decreased. It should be far easier for a researcher to come in and understand how best to manipulate data to make sense of what is very muddy data. And of course, the bottom bullet point also talks about convergence. So it's quite possible that open source software might have different versions, different algorithms, researcher A, researcher B. Both those two researchers might prefer their algorithm. That's fine. But alternatively, both researchers might say, you know, there's a better way of doing this. Let's both adopt the same way to begin to see convergence. You may see 2 or 3 different researchers trying to do things to produce the same answer in different ways, but they produce what looks like effectively like the same answer as well, equivalence. One example, there's my childhood. I remember marathon bars. Now, of course, Snickers bars, they're essentially the same thing, called different things, but you can see there's an equivalence between them. The open source software, the idea is you'd be able to see where you've got equivalence in logic or you get equivalence in answers because with different logic. But crucially, it lets people see what's going on. There's no mystique behind how you came up with an answer using this data. It's transparent. And it's also transparent what the effects on the results are. We've had lots of problems in the past where different researchers, different analysts have produced answers. It's quite difficult to figure out how you got to that answer. Open source begins to break those things down in ways we haven't been able to do before. The other thing to understand is it's also policy. This is not some sort of fly-by-night thing that these programmers with long hair and moustaches and goatee beards like this have sat back and said, this would be cool if we could do this. This is actually policy because it makes good sense. Because it encourages active collaboration through research teams, through analytical teams, and indeed with IT suppliers and clinicians and communities. So the theory of open source is pretty sound. I'll put the link on the bottom there. You'll be able to click through if you look at the slides later. Just NHS England, who's saying this is a good thing to do. It's the same across the UK. I didn't put all the parts of the UK across, but I just pulled a couple of some Scotland's. They've got their data catalogue, and they've also got an open data platform, an open data website which you can look at as well. And again, I think if you click on the Public Health Scotland logo, when you get the recording, you might be able to see that as well. But you can Google it otherwise. So this is not just an English thing. It's not just a UK thing. It's not just a. It's a worldwide thing. So it's a philosophy of open data. You'll see on the second bullet point, there's this thing called GitHub. So one question you might be asking is if researchers are developing all these algorithms, all these bits of software, how the hell do they share it? You can't keep emailing copies. So this thing called GitHub exists, which stores centrally all the software that anybody wants to put on it. So all the open source software that you want to get will be on GitHub. You can access it yourselves if you want to. I'll come back to GitHub in a minute. I just said I'd mention a few other things about commercial open source software, just to show the breadth, the impact it's made in our lives. So I mentioned Firefox, I mentioned OpenOffice. There's also graphics tools. Some of you will have used Photoshop in your personal and professional lives. Well, there's other things called GIMP, which is a open source software which you can download that does largely the same thing. Other ones, Fresco completes with SharePoint, and other ones as well. MySQL is very common around database developers. It's a free, it's a commercial open source software database which manages heaps of data. Database packages, like when I started work doing programming 40 years ago, were hugely expensive piece of kit to buy because it was proprietary software. You had to spend £30,000 per year on a license to do very little, frankly. That world has changed. Open source software makes things much easier. And there are many, many others. There's hundreds of things you could look at if you wanted to look at. So let's think about where you find all this source code, this open source code. And GitHub is where you go. It's a cloud-based platform. It's out there on the web. Anybody can access it with, as long as you've got an internet connection. And this is the place which allows, in this case, let's say analysts, researchers, data scientists, store their code to share it and collaborate on it. So this is the platform that our data scientists across research communities are beginning to use much, much more actively, because it's a really useful way to collaborate directly and dynamically to develop code which can understand the complexities of what's in our patient records to produce the research in the first place. As I said, it's not just a free fall. It does include version control, so you can have different versions of an algorithm, and people can try it and check it. It's got a full change in tracking. So as the community begins to change and develop it, it keeps a record of who's changed what when, lets you navigate through things. But it's become the default tool for all open source software. Interestingly, when I was putting these slides together, I didn't have a clue where the word GitHub came from, so I tested myself. I won't ask you the question because you have to unmute your microphones, but I simply asked my question: where did GitHub come from? It's a weird name. And when I Googled it, when I looked at Wikipedia, very helpful, it said, oh, it's a combination of Git and a hub. Well, thanks for that. I did go a bit further. Git came from a distributed control system software that tracks versions of files. This is version control. So it's existed for a while. And because somebody said, let's have all that version control of algorithms and open source in one place, we'll have a hub, and they call it GitHub. There you go. So that's why it's called GitHub. I learned something putting these slides together. So what about the reality? All this is great in terms of theory about what can be possible. The principle of open source does make good sense. Sharing, learning, collaborating, checking, openness, transparency. It makes really good sense. But is anybody doing it? Well, loads and loads of people are. And a really good example probably the most impactful example in recent years is Open Safely. Now, I don't know whether some of you on the call are involved with Open Safely. We'll be doing a session with them in the not too distant future. But Open Safely, you can read it all for yourself. It's a collaboration of the logos across the bottom to bring together huge amounts of NHS data, primary care data primarily, with other sources of data as well. And as well as having it in a secure environment and running federated analytics, and we've done a separate session on federated analytics. All the software that's used to query that data, to do the counting, if you like, of ethnicity, is all open source and it's all in GitHub. And you can see it. If you want to look at opensafety.org, you can go through and it'll show you all the different code that people used to use the data. The data itself is federated, so it stays out in GP practices, never pulled together centrally. But queries are thrown at the practices, and that's the open source queries that are developed, which you can see on GitHub. So all that code for the analysis is all shared. It's all open licenses. Anybody can see it. Anybody can look at it in terms of scientific review or even curiosity, or as a learning platform. It's all there. So it's a really good example of how open source methodology has worked really well. It continues to work really well. And it's very much the way forward to improve our science, our research, our analysis of data. So what about other sources of open source in healthcare? Excuse me. I Googled this myself and I thought, well, I heard in the past things like medical records were using open source software. And there's a quote there I got, let's go opensource.com again, the link will be on the slides. And I put that in quotations. I thought, oh, that sounds encouraging. Open electronic medical records. Well, the clue there is EMR rather than we've used the word EMR, which is generally an Americanism rather than we use health records over there. So I did a bit of a digging about what the reality is around open source software within hospitals, for instance. How much do they use open source software to do their day-to-day work? And there's an organization called OpenEHR, who I found. I'm sure there'll be others. Please don't take this as the only one. This was just for the purpose of demonstration of this presentation. And they've got a little map, OpenEHR around the world, how the open electronic health record code is used around the world. Well, that looks quite encouraging. And when you zoom in, that's the UK, and you can see actually it's a bit sparser than you might think. There aren't that many instances. This is electronic health records, hospitals using open source software to manipulate our data. So there aren't huge amounts of them. And in fact, if you click on the list option on there, those are the list of hospitals across the UK, list of organizations across the UK that this organization, OpenEHR, says are using open source software as part of their electronic medical records. So not huge amounts. And I've not dug into any of those, the reality of what it is, what it does. But if you want to have a look, you can. The point really is it is being used in some ways, but you don't see every university in the country. Sorry, if you looked at the research side, you probably would see every university in the country saying we use open source, we use GitHub. You may not see the same thing on the clinical records section, but there is some input, some inroads of open source into your own medical records. And I think it's my last example of where open source is used. The NHS app actually says, yeah, we use open source. But when you look down into it, it's actually using sort of fairly standard open source little widgets, little packages that you do see on mobile phones all the time. So browser support needs some little widgets, some little open source packages which do things all the time. JavaScript is a coding language that the web uses all the time. And the NHS app uses little widgets to do with the graphing. So the charts, the graph you see, the developers don't write all that. They just say there's an open source tool called, I can't remember what it is. There's a name, I can't remember the coding it's used. But it's a piece of software that you can use that just graphs numbers for you. That's been developed by the open source community. And that's what the NHS app uses. It makes good sense. They haven't had to redevelop anything. They've not had to pay for developing anything. They've not had to pay license fees, but they've used that software to show graphs on the NHS app. And again, there's a link down there which you can look through if you wanted to see it. It's fairly easy to Google as well. And this is just the ways open softwares become used in virtually everything we do. A lot of the time without us knowing, and other times much more overtly, like Open Safely. So that was my walkthrough of open source. It came from geeky, nerdy software developers wanting to share ideas. developed into something much, much more powerful than that. I think it's got limited impact so far in our medical record management, hospital systems. Lots of bits of open source software used in everything we do all day, every day, on your phones, on your laptops, bits of open source software. It really is used very effectively, becoming very effective in analytics, data science, research communities. So because it makes so much sense, it begins to bring the research community, the data science community together to share knowledge, share understanding, do things faster, and collaborate much more. Multiple organizations find it much easier to collaborate using things like GitHub as their platform than they've ever been able to do in the past. It's faster, it's more efficient, more transparent. You get more consistency and you develop this bigger community. So my take-home message really is if you hadn't heard of it before, keep an eye out for it. You won't see it every day, but you will see open source being talked about more and more, particularly if you're in the research setting. So that was it. I think it was my last slide.